So welcome back guys. I hope you are enjoying this Pandas Essential section. We are learning lots of new concepts in this section. This is going to be the last section in our Pandas Essentials. After this, we will move on and do some practice exercises. In this section, we are going to explore some very useful methods and operations. There are lots of options available in Pandas to explore and get the basic statistics on our data. We have already covered some of them, such as head, is null, drop NA, fill NA, and so on. In this lecture, we will explore some more general purpose operations and revise what we have learned in the previous lectures. Let's create a data frame to get hands-on experience on these operations. I will repeat some values and also generate NaN in our data frame. So just to move on, let's copy this code and run so that we can save some typing. Paste it here and run this one. What we have done, we have imported NumPy and Pandas. We have created a data dictionary here with column 1, some numbers, column 2, again numerical values, column 3 with Alpha, Bravo, Charlie, and some NaN. Then we have created data frame from this dictionary and passed the index 1, 2, 3, 4, and 5. And this is our data frame. Let's start with what we know. We have learned about info. Info provides a concise summary of a data frame. We will use this function very often in the course. Let's call info on our data frame df. So here we have column 1, column 2, column 3, 5 number of values, not null, and the type of the value. So it tells us 5 entries we have, 1 to 5, and a concise summary on the data. The second one what we learned was head. So let's call head. So we know if we don't pass in any number here, the default value is 5. So let's pass in, say, 2 here. So the head is displaying 1 and 2, first 2 rows of our data. Let's try is null now. We already know what is null does. So is null return a Boolean same sized object indicating if the values are null. Let's run this thing and see. So false, 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 and wherever it gets null, it returns true. The next one I would like to use here is drop NA. And let's say df dot drop NA. And if you remember, we have to pass in axis, default is 0. If we don't pass any axis, it will consider 0 as default axis. For columns, we have to pass in axis equal to 1. Let's pass in axis equal to 0 and pass in axis equal to 1 and put them in print statement so that we can get both outputs at the same time. So let's run this cell. So this output is from the first statement and this output is from the second statement. When axis is 0, it's dropping the rows that contain NaN. And when axis is 1, it's dropping the column which contains NaN or null values. So the next one, let's try fill NA. df dot fill NA, and we know we can pass in value here. We can use method. Let's pass in some value here. Say x, y, z, and let's run this cell. So we have wherever it got the null value, it's filling with the given value x, y, z. We can do forward filling, back filling, and so many other options available in fill NA. Let's try ffill or forward fill. So instead of passing value here, we need to pass in method, which is what we want to know, ffill. So forward filling. Let's run this code. So now we have these two were NaN or null values, and the forward filling is filling these null values with Charlie, which is the previous value. So the next very useful method that we will use in the coming lectures during data analysis, visualizations, and machine learning, some exploratory data analysis, is unique. So if we want to know how many unique values are there in column 1 or column 2 or column 3, let's try unique on all these three columns one by one. What we need to do, we need to grab the column one by one, call 1, and call unique. So let's run this, and we have 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. We have 5 unique values in column 1. Let's call this one on column 2, copy and paste, and run this one with column 2. So we have 1, 1, 1, 2, 2, 2, 3, 3, 3, 5, 5, 5. 4 unique values in column 2. Notice that 1, 1, 1 appeared 2 times in the column 2, but in unique it's only appeared once because we want to know the unique values. Let's apply the same one on column 3, which is string column, so it works on strings as well. Let's run this code, and we have Alpha, Bravo, Charlie, NaN. Once again, notice that NaN is twice in our, this is our original data frame. So NaN appeared 2 times in column 3. However, it only appeared once in the unique operation. Rather than displaying values, we can display the count, how many, that is n unique. Rather than calling unique on each column, let's try n unique. So unique and n unique, we only need to add n at the beginning of unique. And if we run this thing, we are getting 5. So we have 5 unique values in our column C1. We can call this on another column, call 2 dot n unique, and see how many number of unique values are there in column 2. If we run this thing, we get 4. So in the column 2, we have 1, 2, 3, and 4, and n unique is returning the count. Another very useful function that we will use quite often is value counts. So what if we want a table with all the values along with number of times they appeared in our data? Value count do the work for us. Notice that for NaN, it counts a missing value and does not do anything in the output. So let's apply value counts on column 1 using dot operator, value counts, and let's run this cell. So here we have 5, 1, 4, 1, 3, 1, 2, 1, and 1, 1. So if we look at this one, 5 appeared once, 4 appeared once, 3 appeared once. So it is telling us these values are appeared only once in our column 1. Let's try the same value counts operation on our second column. Copy and paste and change this to 2 and run this cell here. So now we can see 1, 1, 1 actually appeared 2 times in our data frame, And value count is telling us 111 exists 2 times in column 2. However, 22 is 1, 33 appeared once, and 55 appeared once. So once again, I want to mention that unique and unique value counts are 3 very useful and frequently used methods, which are associated with finding unique values in the data. The next I want to introduce is sort values. So let's call df dot sort values, and if we press Shift Tab, we have by axis ascending true, which is default, in place false, which is default value. For permanent change, we have to pass in true. So moving forward, let's pass in by and work with all default values other than by. So we want to sort our data by, say, call 2. And if we run this cell, here we have 1, 4, 2, 3, 5. So according to column 2, 111, 111, then 222, 333, 555. So once again, if we explore the document string, the ascending is true. This is default. So the results are in ascending order. So moving forward, let's talk about data selection now. We have learned to grab data in our previous lectures. We know we can grab a column with its name, do the conditional selection, and much more. We can use LOC and ILOC to find rows as well. Let's revise the conditional selection here. So what we did, df, and let's apply condition on column 1 and say greater than 2 is our condition. So it's returning false where the condition is not satisfied. However, wherever the condition is satisfied, it is returning true. So this is actually a Boolean mask. We have already used such mask to filter out the data. Let's try to create a Boolean mask with 2 conditions on column 1 and column 2. Say on column 1, we want this condition, and let's put it into the parentheses. And the second condition we want on df, say call 2, and we want the values which are 1, 1, 1. So these are our 2 conditions. Let's pass in this to a variable bool ser and run this cell. If we print this to ser, we have false, 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 true, false based on these 2 conditions. So we can apply this bool set to filter out the data from our data frame. So what we did, if you remember, we need to pass in this mask in square brackets, and let's run this thing. So here we have 4, 4, 1, 1, 1, and an. It's filtering out the values according to the condition provided and returning where it is true only, which is 4. So moving forward, let's learn another useful method, apply. Indeed, apply is one of the most powerful Pandas feature. What we can do with apply, we can broadcast our customized functions on our data. Let's see how we can broadcast our customized functions on our data. We have already learned apply in the previous lectures, and this is a revision, and I hope you remember the previous lecture as well. So let's create a function def, say square, and pass in a parameter value colon, and the function returns value square. So Let's run this cell. So we have a function square. Let's broadcast our customized function square using apply method to calculate square of any column in our data frame. Say we want to calculate the square of column 1 in our data frame. So what we need to do, we need to grab the column 1 from our data frame and using dot operator call apply, and then we need to pass in the function. So our function is square. Copy this one, paste here. What we are doing, we are grabbing the column 1 from our data frame and using apply method to apply our customized function square on the column in our data frame. Let's run this thing. So here we have the square of the column 1 using apply 1, 2, 4, 6, 8, and 10. So the same operation can be conveniently carried out using state-of-the-art Lambda expression. So rather than defining a function and then applying using apply method, we can conveniently carry out this operation using state-of-the-art Lambda expression. Let's try Lambda expression instead. Copy this one, paste it here. Instead of square, we want to apply Lambda expression. So what is the syntax for Lambda expression? It starts with keyword lambda, L-A-M-B-D-A, and then value. And what we want to do with value? Value square. So instead of this function, we are only using Lambda expression and passing this to apply method. Let's run this thing. So here we have the same results. We know we can use built-in functions with apply as well. Like we want to find the length of a string in a column. So we have column, this 3 column where we have strings. Let's find out the length of the strings in column 3. So df, grab the column 3, col3, and let's select 0 to 3. First 3 values are not null, and apply len, which is a built-in function. Let's run this code here. So we have in the first row we have 5 the string length, second 5, third 7 string length. So we are avoiding NaN or null values for column 3 here. Let's try to delete this thing and apply. So here we have the type error. So we have object of type float has no length, type error. This is why we selected from 0 to 3. So it means the NaN has a float type and that doesn't have length. Let's check the type of NaN now. np.nan. So this is float type. So just to avoid this type error, we passed in 0 to 3 here. And here we have the same output again. So a couple of more things to know. We can get the index of our data frame using df.index. So our index is 1, 2, 3, 4, and 5. We can get the columns like df.columns, and we have call 1, call 2, call 3. If we want to drop any column, we need to call df.drop. And if you remember, we need to pass in column name and then tell the drop the axis as well. If we run this thing, it's going to raise an error because it does not find call 1 along axis 0. So label call 1 not contained in axis. We need to tell that the axis is 1. And if we run this code again, it's dropping the column 1 and returning the rest of the 2 columns in our data frame. If we output data frame again, the column 1 is still there. To get permanent change, we need to pass in place true. So we need to run this cell, and now if we run our data frame, we have column 2 and column 3 because it is permanent change for in place equal to true. So we have deleted the column col1 using in place true. Let's get that column back into our data frame. We can simply run the cell where we created the data frame. Let's go back and so this is where we created the data frame. Let's rerun this cell. So now we have our data frame into its original state with column col1, col2 and col3. Actually, I need all these 3 columns in the next example. So let's move on. So moving forward, another very useful method is pivot table. What pivot table does, it creates a spreadsheet style pivot table as a data frame. If we want df dot pivot table and read its documentation as well. So create a spreadsheet style pivot table as a data frame. The levels in the pivot table will be stored in multi-index objects, which is hierarchical indexes on the index and columns of the result data frame. So we have some parameters that we can pass in, and this is a very common example which is given in the data in this document string. If you want to know, you can read this document string. Let's apply this pivot table on our data frame. So df dot pivot table, what we want to pass in values. Say our values are col2, and we want column 1 as index, and then we want columns as col3. So what it will do, it will take the values from column 2, set the index from column 1, and set the columns from column 3. So Alpha, Bravo, Charlie would be our column names, and values would be column 2, and index would be our column 1. So let's run this cell and see how the output look like. And here we have values from column 2, and wherever it didn't find the value, it is putting NaN, index from column 1, and column 3 is our Alpha, Bravo, Charlie. So NaN appeared for missing data. NaN in column 3 will not be used for the column names in the pivot table. This is why it is skipping index 4 and 5, because for index 4 and 5 we have NaN in the column 3. Let's look at another example. This example, I will copy the code from the reference book again. So here we have a data A, foo, bar, 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 B, 1, 1, 2, 2, and 1, 1, C, and D. And we are creating a data frame foo bar from this dictionary. Let's run this thing and print this foo bar to see how this data frame looks like. So we have a data frame foo bar. A, B, C, D are columns. A is foo bar bar. D is 1, 1, 2, 2, C, X, Y, Z, and D is a numeric column. Let's create a pivot table for foo bar. So foo bar dot pivot table, and we want values, let's say D, which are numerical values. So we want values as D, and we want multi-level index, and let's pass in index A and B. So index equal to, we need to pass in the list here B, and then we want our columns as C. So let's pass in columns equal to C. So what we want to do, we want this D column to appear as values in our pivot table. We want multi-level index A and B, A column and B column, A as level 1 index, B as level 2 index, and we want columns from C. So let's run this cell and see how the data looks like after pivot table. So here we have A is our bar and foo, B is our 1, 2, 1, 2, and it is getting values from D, and wherever it did not get the value, it is putting NaN. And columns are XY, XY, XY. These are our columns. So this was all about useful methods and operations in the Pandas. So we are done with Pandas Essentials. I know it was extensive learning for you guys, but I hope you have enjoyed this journey with me. We have learned lots of key concepts in Pandas Essentials, and we are going to apply these concepts in the coming lectures. See you in the next lecture. Good luck.